video. In this video, we'll be looking at reversible reactions and equilibria. So the learning outcomes will be, you will be able to understand what a reversible reaction is in chemistry. Also, we look into the phenomena of equilibria, and also we learn a new principle called the Le Chatelier's principle, which is associated with this phenomena equilibrium. All right. So the first question, what is a reversible reaction? So in chemistry, we have two types of reactions, which is irreversible reactions and reversible reactions. So when you have the most commonly used type of reaction that we have seen so far might have been the irreversible reaction. That means, for example, if you look at this reaction here, you might only have seen reaction with one arrow, right? But in reversible reactions, you associate reactions that are able to move in this forward direction and also in the backward direction. So if you move in the forward direction, A and B will be your reactants and C and D will be your products. Vice versa, if you move in the backward direction, C and D will be your reactants and A and B will be your products. Okay, so a real life example of this type of reaction, we can see this is nitrogen plus hydrogen gives you compound which is ammonia. So production of ammonia is a reversible reaction because you can produce ammonia by these two elements, and ammonia can break also into nitrogen and hydrogen. So this is the ideal example for a reversible reaction. So be mindful of these half arrows. So you are representing a half arrow, you're not representing full arrows. Half arrows pointing into opposite directions. Next, we'll look at equilibria. So equilibria means, so maybe in physics you must have come across this word equilibria. Now equilibria means you are trying to balance. Okay, there's a balance. There's a definition maybe of equilibrium, right? The balance. So here what we are trying to do is we are trying to balance this reversible reaction, the right hand side and the left hand side, right? So both sides we are trying to balance it to keep this equilibrium constant. Okay. So what happens is for a reaction to achieve equilibria, there are a few conditions. The three conditions are the rate of the forward reaction should be equal to the rate of the backward reaction, and this particular reaction should be conducted in a closed system. I think that's more understandable as to why it is so, because when you're doing it in a closed system, you don't have external factors that would harness or change the equilibrium state. All right. And the other thing is that the amount of reactants and the amount of products should be same. That means the amount of material on the right hand side should be equal to the amount of material on the left hand side. Simple as that. All right. So if you have all these three conditions satisfied, then you have achieved equilibrium. All right. You are in your reaction in state of equilibrium. All right. Next, we'll look at Le Chatelier's principle. It's a very important principle, and this is the most important. This is the most important section of this entire equilibria and reversible reactions lesson. All right. Now, what this who if someone asks me who Le Chatelier is, Le Chatelier is a scientist who found this particular concept. Now, in this concept, what it means is, so say a reaction is in equilibrium, right? Your chemical reaction is in equilibrium, it's perfect, but you do a change to it. Okay, so you change certain factor, maybe temperature, maybe concentration, maybe something like that. You change, Why do we change? Because as human beings, we want uh, the fundamental things to be changed in order to achieve our goals. That's the main idea. So once you change certain factor, the state of equilibria will be destroyed. Okay, so that means that reaction is not anymore in equilibrium. Okay, so what does a reaction do? Reaction does not like to be, it likes to be in equilibrium, but now it is not in equilibrium, so it tries to find a way to achieve or to regain this equilibrium. So it will favor the reaction or the side, the direction of the reaction, which opposes this particular change that you have done. Okay, so it's basically finding the direction of a reaction where you can eliminate this change and regain equilibrium. All right. So temperature, pressure, concentration, these are the most commonly common factors that are being changed in order to achieve what we want. Okay. So let's move on to the next slide. So let's go for temperature. Okay. Now you have this particular reaction. It's a reversible reaction. This methane plus water gives you carbon monoxide and hydrogen. So it's a reversible reaction. Okay. So say we are trying to increase the temperature or decrease the temperature in a reaction like this. Okay. So if you increase the temperature of an endothermic reaction, so if the forward reaction is endothermic. How do I know the forward reaction is endothermic? Because normally when a certain reaction is given like this and the enthalpy change is given on the side, this is actually the enthalpy change of the forward reaction. Okay, so here the enthalpy change is plus 210. So that means I know the forward reaction is the endothermic reaction. Okay, so keeping that in mind, that the forward reaction is endothermic, if you increase the temperature, the forward reaction will be favored. And more of the forward reaction production will be formed. That's true. That means in this case, carbon monoxide and hydrogen will be produced more and more. If you decrease the temperature, it will be the other way. It will favor the backward reaction and methane and water will be produced. All right. So if the forward is exothermic, what is going to happen? If the forward is exothermic, if you increase the temperature, the backward reaction will be favored. And more of the backward reaction products will be formed. And if you decrease the temperature, the forward reaction will be favored and the more of the forward reaction products will be formed. So remember this pattern. This pattern is very easy because normally in exam, this is the thing that they ask you. They basically say, okay, we are changing this particular, maybe they will give you a reaction, they will give you the enthalpy change, or they say whether it's a forward reaction endothermic or exothermic, and then they will tell you what's happening. So remember this, keep this also in mind. So whenever if the forward reaction is endothermic, definitely the backward reaction should be exothermic. If the forward reaction is exothermic, the backward reaction should be endothermic. They can't be both endothermic or they can't be exothermic. Think why is it so? Okay, think why is it so? Last slide, we have concentration and pressure. Now concentration and pressure both are very similar because concentration we normally associate with liquids and solids, but when it comes to gases, we associate with pressure. All right. So what happens if you change this? So here we have got this example of the production of ammonia. Okay, N2 plus H2 with the ammonia. That reaction we are using as an example here. So if you increase the pressure or concentration, so let's take the pressure in this case because we are associating only with gases here. So if you increase the pressure of the above reaction, okay, the reaction will favor the side which produces the less number of molecules. So in this case, which side has less number of molecules? See on the left hand side on the screen, you will have 4. You will have 1 of nitrogen and 3 of hydrogen. That means you have 4 molecules total on your left hand side. Whereas on the right hand side, you have only 2. That is definitely on your right hand side, you have only the right hand side, you have less molecules compared to your left hand side. So if you increase the pressure, it will favor the reaction which is able to produce you the less number of substances. So in this case, the forward reaction will be favored. Why does this happen? Because remember, according to Lesch-Hafier's principle, we are trying to get rid of this particular chain that is happening, that has harnessed our equilibrium state. So what we do is we're trying to eradicate this external pressure that is added to the system. Vice versa, if you decrease the pressure of a reaction, then it will favor the side that produces the greater number of products. So in this case, the backward reaction, if you move in the backward side, the nitrogen and hydrogen will be produced more and more because that side has more amount of molecules or substances there. So that in that way he is able to regain, the system is able to regain the lost stability or the lost equilibria of the reaction. All right. So in this, with that we come to the end of this video. So in this video we discussed about reversible reactions, and then we discussed about the characteristics of a reversible reaction, like the half arrows. All right. And then we came to the equilibrium. Equilibrium, we discussed that there are three conditions that need to be satisfied in order for us to call it equilibrium reaction. And then we came across the Lesch-Hafier's principle, and we learned about what happens when certain factors are changed. So keep in mind all these factors, the factors related to temperature, factors related to pressure of concentrated also. So go through this video, and that's it for this video. I will meet you in another video. Thank you.